The previous sample aid video showed it helping to sample a microKORG synthesizer onto an EMU hardware sampler, and this video shows how to sample multiple velocities for use with velocity crossfading. So why would you want to do this? Well, this example program shows how the note velocity, or how fast the keys are being pressed, affects the tone, in this case the filter cutoff frequency. Now if we just sample the notes at one particular velocity, they won't sound as dynamic when you play them back on the sampler. The volume will change okay, but not the timbre or tone of the sound. So one way around this is to sample each note at several different velocities and then blend them together on the sampler using a technique called velocity crossfading. Right, we'll need to generate a set of notes at specific velocities on the microKORG, and as this can be difficult to do consistently by just pressing keys, I'll drive it with a MIDI connection from the sample aid tool, which is running on a netbook PC with a USB to MIDI adapter. The previous video sampled all notes at maximum velocity. In this one I've reduced the limits just to save time. I'm sampling every 3 notes from C1 to C3, which makes 9 steps. But more importantly, I'm using 3 velocity steps from 47 in steps of 40 up to the maximum 127. So this makes a total of 27 samples. Now before we start, we need to think about how to organise the samples after they're captured. And we want to crossfade each of the 3 velocities. So we could choose to crossfade each sample, in which case we'll have to change 27 items. Or we could assign all the samples in each velocity band to their own voice and just crossfade the voices, in which case we'll only have to do 3. The sample aid tool can generate notes in either pitch order or velocity order. And as we want to populate each voice with a batch of pitches at one velocity, we'll set the sequence to pitch order. Now if we reset the pitch and velocity to their start values and click play 1, you'll hear the pitch changing first, then the velocity. And just for interest, velocity order would sound like this. Now you could just run the whole 27 note sequence like this, then create the voices afterwards and move the samples into the correct voice. But with the EMU, if you create a new voice at the start of each batch, it does all this for you. The downside is that creating a new voice in full auto mode can get a bit frantic. So I'm going to use this velocity hold control to slow things down a bit. This stops the velocity changing automatically, and so it stops the sequence at the end of each batch of pitches, which leaves you plenty of time to set up a new voice. And then when you're ready to resume, you just use the manual buttons here to set up the next batch and press play 1 again. Right, all the sampler configuration was shown in the previous video, so we'll assume that's all been done. I'm going to use a note on time of 500 milliseconds and a note off time of 5 seconds, which should just give me enough time to arm and place the sample on the sampler. Now if you want to use the EMU auto naming system, don't forget to name the current preset first. And while you're at it, if you also want to use different names to identify each velocity band, just change the preset name before you start each batch. For example, we're starting with velocity 47, so we can add that to the name. We'll press preset manage, name, this is the microKORG, and we'll say velocity 47. Then go back to create sample. Now we'll start sampling. Press ARM on the sampler and click play 1 on the sample aid tool. Now we just stay on the sampler and keep pressing place and arm until the batch is finished. Now if you're doing a lot of samples, as mentioned in the previous video, the only problem here is falling asleep. It's very hypnotic. Okay, the sample batch is finished, so I can stop this one. Now the sequence has stopped automatically at the end of the batch because we use this velocity hold option. If we hadn't pressed that, the sample aid tool would have carried on with the next velocity range automatically. Anyway, we've now got plenty of time to set up the voice. Now if you're naming the samples with the velocity value, now's a good time to nip back to preset manage, and we can rename the preset. On the tool we can prepare the next velocity batch, which is 87. So we'll name this 87. Okay, back to the create sample page. Now we just need to set up a new voice for this batch, and you can do this on the EMU by changing the group number just before we place the next sample. Now one way of doing this is just to force a dummy sample, so we can press force, it just samples nothing, but on this screen now we can change the group number. I'll just increment it to group 2, and we'll just dispose the sample. But what's happened is the EMU's created a new voice ready for the new group, and it will continue to use this from now on. So now we can continue sampling. Press arm on the sampler, play 1 on the tool, and we're back to place and arm. Now I've looked in the MIDI spec for the EMU and I can't find a way of automating these two buttons, which is a shame. Okay, end of batch. Stop that. On the tool we'll set up the next batch ready. Click this manual button. The next one will be velocity 127. We're going to name the preset. Preset manage, name 127. Back to create sample, and we'll make a new voice, force, and we'll use group 3, dispose. Right, we're ready for the third and final batch. Arm, play 1, place, arm. Okay, that's it. Now if we go to preset manage, you can see a summary of the preset, and it's showing us there's 2.57 megabytes worth of samples in this preset. You click preset edit, and this shows how the samples are organized within each voice of the preset. This is voice 1, group 1, and here are the first 9 samples. And the names of the samples are made up from the original preset name, followed by the note name. And the note name is derived from the MIDI signal that goes into the sampler. Now that's important not just for the name, but for this value here, the original note value. And the sampler uses that to know whether to stretch the sample or not on playback. So if you don't have this automated, you'll need to set the original key value as you're sampling. This is voice 2, group 2, and now we have sample 10 to 19. Voice 3. So the name, which includes the velocity value, is quite useful, for me at least. It's not essential, as all these samples have got unique numbers. But at least it shows we've got them batched up correctly. Each voice has got its own velocity band. Right, if we press page next, we go to the key window. And this shows how each sample has been placed onto the MIDI range. We sampled every third note, so each sample will be used to play 3 consecutive notes. We'll take sample 3, which is F sharp 1. It will be used to play F1, F sharp 1 and G1. So an incoming note with a pitch corresponding to the sample's original pitch, in this case F sharp 1, will use the sample unchanged. But the other 2 pitches are created by stretching or shrinking it. Depending on the type of sound, this stretching may cause audible jumps as you go from one sample to the next. And this is demonstrated in the sample aid audition mode video. Now for the velocity crossfading, scroll to the right again. Now the previous key window showed which samples will be used depending on the incoming key or pitch, whereas this velocity window shows which samples will be used depending on the incoming velocity. Now at the moment these bars show that all voices and all samples will be used for all velocities. So we need to restrict the ranges to our 3 velocity bands. Now as mentioned before, you could either change all samples by altering these values here. You see the bars changing. But we'll need to do 27 of these. So you could just do the voice. And this affects all the samples within the voice, so it's much easier. The low and high values define a threshold point, and the samples will switch abruptly at that velocity value. So if we say voice 1 goes from velocity 0 to 47, which was the value used for this batch of samples, then we can go to voice 2, and put the cursor over the voice value and press ink, it will go to voice 2. We can now alter the low and high values for voice 2 and say this one starts at 48 and finishes at 87. And then voice 3 88 to the maximum 127. So we'll go back through the voices, and you can see how the bars span the whole range in batches. Now if you set it up like this and play the preset, you'll hear the differences between the 3 ranges. So we can use a crossfading technique, and that's what the fade values, low and high, are for. As we adjust the fade, you can see the graphic representation of the blending of the velocities. That's the low end, and this is the high end. Now we want the actual thresholds to overlap, so we may say make this 67, add 20 to the original value, and fade it by 20. The next voice. Right, here are the 3 fades now. Voice 1, you see the fade here. Voice 2, the fade in, fade out. And voice 3, the final fade. And really you just need to tweak and test all the values for each of the 3 voices until it sounds okay. Okay, so what does it all sound like in practice? This is the original sound from the microKORG. Okay, now we'll play the individual voices on the sampler. I've soloed each voice, so there's no velocity switching or crossfading. This is just to show what would happen if we sampled one particular velocity. So if we'd sampled everything at velocity 47, we'd get this. Voice 2, which is at velocity 87. And voice 3. So although the volume gets louder, the actual tone does not change. So now we'll try velocity switching. So this is with the fade values set to 0, and I've set the thresholds at 47 and 87. So you can hear the abrupt changes in sound. Now that sort of thing is also demonstrated on the Sample Aid audition mode video, where I check out a Yamaha electric piano, which is a sampled instrument. You can hear quite clearly the jumps in sound as the velocity changes. Here's the velocity switching with crossfading. I've adjusted some of the fade values from earlier. It's by no means perfect, but you should hear a difference. So there is a smoother blending of the different velocities. To get an even better result, we need to sample more velocity layers. If we look at the pitches, there don't seem to be many glaring jumps as I go from pitch to pitch. So sampling every 3 semitones was an acceptable compromise for this experiment. This is very dependent on the type of sound. The ideal situation would be to sample every semitone, and the sampler would not need to stretch or shrink anything. Okay, that's about it for now. I hope that's helped, and thanks for watching.